these tons of data of the geologic investigation, we just made this kind of map of the probability of large earthquake for the next 30 years for these active faults. So red one is the very precocious ones, very dangerous ones, and the blue one is relatively safer ones. But you can see that 3% or 0%. So we are struggling to just transmit our knowledge to people because weather forecast this country. So probably Japanese people bring the umbrellas when we see that the 40% of rain chance, but see 3% or probably. So these are top 5 active faults, but the maximum one is 16%. So it's lower than the weather rainy forecast. So we struggle to a little difficult to explain, but 980 gal, the unit of the acceleration, gal, it's 1g gravity acceleration. So it's half of the gravity acceleration that recorded in the this village and these villages. And you see many houses of collapse, but there was a miracle, nobody was killed. And probably, like 250 houses was collapsed by the earthquake shaking. And well, how about prediction of this earthquake? And we just forecasted the magnitude 7.5 earthquake, including the section of Hakuba, using the topographic information, and then also paleoseismic trenches. And this is just a lake deposit. So the sediments normally tend to deposit like flat, horizontal, but now you see it's really like a curved, right? Tilted by the movement. And so the size of earthquake was huge. So we expected, so this is just a prediction of a large shaking in this area, Nagano and Ueda, Matsumoto, Suwa, you're not familiar, sorry. And the red one is the area, the intensity is 6 plus and 7 some. But luckily, that the earthquake we had is really small. The only this section was ruptured. And then observed intensity distribution, ground shaking, was limited to the northern part of fault zone. So we actually underestimated the size of the earthquake. But we also expected the many other earthquakes, just the rest of the fault zone. And well, this is the new problem issue for us, because we just expected the we learned active fault in time that moves every 1,000 years or every 10 or 20,000 years, something like that long. But when we study this fault, like a trench excavation, we found that the last event before the 2014 event was 1714 AD. So which means only 300 years ago, similar earthquake happened from this geologic record. So this was just tilted the road by the 2014, and we found fault here. So it's hard to see. It's a really technical. And we found the evidence that only 300 years ago, the similar event happened in this site. Well, this was a really new finding. And this raised question to the scientists that we have to think about the recurrence interval of a large earthquake. And how about the Kumamoto? Again, and this is Kumamoto earthquake, and this is just a typical scene of the landslide, and that just forced just loaded the bridge of the Aso Ohashi and collapsed. And this is the typical scene that we saw in the village of the Mashiki and the village of Nishihara. It's a suburb of the city of Kumamoto, and which totally devastated the typical Japanese wooden houses. And so this is a really sad scene that we saw. The first floor just completely crushed, and that floor was used for the parking space. And you see many just cars smashed by the what we call the pancake crash, pancake collapse. And the another scene that we saw here, this is the car, is completely smashed by seismic wave. So some seismologists argue that the acceleration was probably all 1g. So which means that the object just fly over, and then this car was knocked down by the seismic wave. And why Kumamoto? Well, actually we knew that Kumamoto or Central Kyushu is so active in terms of earthquake activity. So this is the northern part of Kyushu Island, and the Beppu. Have you ever heard Beppu, Oita, and Aso and Unzen? They are very famous for the active volcanoes and then also hot springs, onsen. That's because the Earth's crust was stretched, fractured. So that means lots of fractures, and we have path or conduit of the magma and then also water. And which means that we have many volcanoes. We not only have many volcanoes, but also many fractures, which means active faults in this area. So what we call the Beppu Shimbara graben. This is just a technical jargon, but we call graben. And then earthquake happened in the southern marge of this Beppu Shimbara graben. So when we went to the site, we saw this kind of the surface break, fault. You see, this is the typical Japanese footpath of the paddy field. But it was straight, but it's now shifted like this. Or we said offset. So this is a right lateral offset. So I need to have some time. I need some time to explain that what the difference of right lateral and left lateral. But if you stand here and then look at this person, if this person goes to right, this is right lateral slip. If this person goes left, this is left lateral. It's like slip fault. And this is another one. So we measure 2-meter slip of the this footpath also in this field. And so this is the rails of the local train, and it's now also offset. This fault line is here, and so this is another one. So this is just a plastic cover for some agricultural product. You see, this is just a fracture zone fault, and actually, I'm afraid to say we were predicted for these fault lines because we mapped blue lines. These are active faults before Kumamoto earthquake happened. And this is a Futagawa fault, what we call, and then this is Hinagu fault, and this is a huge caldera, Aso volcano. And so the fault reached to the caldera, and the epicenter is of the magnitude 7.3 earthquake here, and then we observe such a surface fault slip, and then mapped as red lines, and part of the rupture reached to the city of Kumamoto, but very tiny, few centimeters, and also reached to the within the caldera of Aso, and well. Many Japanese people and probably media just misreading to the people that the only risk is only or along the active fault zone. But important point is active fault itself doesn't produce any intensity 7 severe shaking. We definitely need soft ground, very vulnerable, weak ground. If just the house is standing on the very hard rock, the shaking was normally weakened by such a stiffness of the rock. So let me explain to you that this is just an active fault zone, and this red area is an area that experiences severe shaking, intensity 6 plus here. So you see, it's not on or along the active fault, but rather it's extended to the city of Kumamoto, extended to the northern part, which is really soft because of the volcanic ash from the Aso caldera. And one of the seismic stations that recorded the 1362 gal, which is probably 1.5 times of the gravity acceleration. So it's huge at the surface. But they also recorded the acceleration at the depth of 250 meters. So it's about 1/5, right? It's not so strong. So which means, well, this is also a misunderstanding that people have that in the subway. So subway is much safer on the surface if you don't have any panic. So this is just a real situation we measure. So let me show you this is seismic hazard map in Japan, and red one is just high earthquake, subduction earthquake, and then Kanto earthquake. So you are in the high risk zone, and so the people think that these orange and yellow zone is safe, but the recent inland earthquake since the Kobe earthquake happened in yellow and orange zones. So this is just a challenge to us, right? And the Kumamoto one is here, and then this Niigata and Narano, and then Fukushima and Iwate. Well, but you see, these all seismic sources, including subduction, offshore earthquakes. So if we restrict on the active faults, we see that the high risk region is Niigata or Nagano or Kansai, Kyoto, Osaka. And then if we magnify the area of Kyushu, you see that Kumamoto and Oita, Saga is in red. Right? So that means that we have already published these kind of maps, but unfortunately people didn't know this Kumamoto was in high risk of large earthquake. And we also released a map of the predicted intensity, shaking intensity of Kumamoto area using fault information. And this is a prediction. And we expected some small area of intensity 6 or no 7 area. But the results is, the area is much wider than our forecast. So, which was actually the problem. The size of earthquake we forecasted was 7, but actual size that the Kumamoto earthquake was 7.3, probably a few times larger than just 6 we forecasted. So we're still in struggling to make such a kind of forecast to notify the people about the risk of the earthquake. And another hazard is the fault movement itself. And this is the one of the class apartment in the Aso. And fault actually cut the base of the apartment. And you see, the first floor was just completely crushed by the movement of the fault. And this is dam reservoir. And then it's cut by the fault. You see that these fractures. This is the fault zone. And fortunately, the dam itself just lets the resisted to this kind of movement. And well, the water leak occurred, but no collapse occurred after the earthquake at the Kumamoto.